So today we are going to do redox and electrode potentials, but all those questions you're going to get in the exams to do with redox and those electrode potentials. I am wearing my favourite team's top, which is Leicester Tigers, so come on the Tigers, right? And obviously this afternoon I'm going to be watching England play rugby as well, so I'll get this film done and then I'm off to watch. Anyway, so if we look here, we have got exam style questions, redox. Let's go for the first one. So we've got a redox equation that we have to balance. Okay, and I need to know what the number is for H plus. So let's move that on and move it to the side. Okay, and then go through how we do it. So we are going to put 0 for this. This is how we do it. We go through the oxidation numbers, 0 for that, and we'll go across here. Okay, so that's plus 1. Okay, and let's have a look at the other side first. Plus 1 and plus 1 there. So I'm not going to write that because it's plus 1 here and it's plus 1 there. What we're doing is finding out which one of the oxidation numbers has changed. So if we look here, the oxygen is -2. Oh, it's -2 over here, -2 here. So I'm not going to do the oxygen either. But I'm going to do the nitrogen because the nitrogen changes from +5 here. So I'm going to put +5. Okay, and then let's put the calcium because we know that changed. Okay, so that's going to be +2. Okay, and then the nitrogen here is going to be +4. Okay, so we've got all these numbers and we need to make the electrons balance. Okay, as you've seen in a previous video. So we're going to make the electrons balance. We know from here to here, okay, we are lose 2E minus, okay, and then we're going to go from here to here, which is gain 1E minus, okay, so gain 1E minus. Right, well that means basically we need to make these the same. So I want 2E minus here instead of 1, because that will gain 2 and this will lose 2. All right, so what we do in here is just put a 2 here. Now what that will do, okay, I can balance everything from that, okay? So basically I've got a 2 here, which means I'm also going to need a 2 here because I've got to balance my nitrogens. Okay, and then from there, my calciums are balanced already, so they're fixed. And then I can go for the amount of oxygens that I need. So if you look here, I have got 4 oxygens, okay? And here I have got 6. So I've got 6 there. So I've got two spare oxygens, if that makes sense. Okay, so remember I've got 6 here. I have got 4 here, 5 here. Okay, so 5 oxygens on the right and 6 here, right? Which means I need to balance that out. So basically what I need to do is put 2 of my H2O. If I've got 2 of my H2O, that means my oxygen's balanced. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, my oxygen's balanced. I'm doing that to balance the oxygen. That tells me how many hydrogens I've got, which is 4. Okay, so I go back over here and I put my 4 on. Okay, so there's my 4, and then I know my answer here is B. Okay, and that is probably one of the most complicated ones you'll get. Okay, so make sure you can do redox and make sure you can balance redox equations. So the next question is looking at which one of these half cells that we've got would be the positive electrode of the cell. So the first thing you need to remember is that the positive electrode at the cell is the one where the element or the solution gains electrons. Okay, so it's really important the positive one gains the electrons. And electrons are negative, so the one that is the most positive gains the electrons. Okay, so that means of these two, this one is the most positive. Now let's put the answers that they give you up on here. Okay, so they're telling you that this is set up here with this one, and they're basically going to put them the right and the wrong way around as well. So there's one way here, and then one way here. They've just reversed the two. So I'm saying that this one is the most positive, therefore it's going to gain. So to gain, it goes in that direction. So Au3 plus 3 electrons, which means the answer is going to be C. Our next question is going to be about balancing a redox equation. Now I've done some of the working out already for you, and I'm going to show you that in a minute. We're going to take Fe2O3, can be oxidized by bromate. Okay, there's your bromate here. Okay, and there's your iron oxide. Right, so we've got 2 half equations. You'd be given these 2 half equations, and you'll be expected to balance them and then join them up. Okay, so if we're going to do that, I've done the one at the top already, so what you can see is I found out that the bromine was +1 and it went to -1. So I balanced the one where the oxidation number is changed. That's how you do these half equations. They're 1 each. Then I go to add as many oxygens on this side by adding water as there is on this side. So there's one oxygen this side, so there's one water this side. Then I add as many hydrogens to cancel out those hydrogens that are in the water, and there's 2. And then I look at the charge on each side, which is +1 and -1, okay? And I add enough electrons to bring the positive side down to the negative sides here. So that's 2 electrons, that brings it down to the same charge. So we've got both halves the same side. Now I've partially done the next one for you. Okay, so if we look here, this is +3 because the oxygen is -6. So -2 times 3 is -6. Okay, and that means each ion here must be +3. That's important, each ion is +3. There are 2 ions, remember? Okay, now that's going to +6, because if I look here, okay, and I look at this Fe here, there's 4 times -2 for that. There's a -2 left over, which means this must be +6. Now, that means it's changing oxidation number, so we need to balance it. So that basically means I need to go up here and put a 2, because I need to make sure the Fe balances on each side. Then I need to look at this and go, right, how many oxygens are there? Okay, well, there's 4 on this, sorry, 8 on this side. 4 times 2, don't forget the 2. 4 times 2, and there is 3 on this side. Okay, so we've got 3 on this side, and we have got 8 on this side. Right, so the difference is 5, so I've got to put 5 in there. Okay, so we've got 5H2O. Then that means on the other side, I've got 10H plus, okay? So, a bit more complicated, all right? Now, if that is 10H plus, that means basically that this side is completely neutral. This side is 4 minuses plus 10 pluses. Okay, 4 minuses plus 10 pluses is going to be 6 plus, or +6, okay, overall. So it'll be +6 overall on this side, 0 on this side. So I need to add enough electrons to get it back down to neutral, and that's 6. Okay, so we've done that, and there's our balanced equations. Now, if we want to combine them together, we've got to make sure that the electrons are the same number. So this means this one has to be times by 3, okay? So basically I have to put 3 here, and I have to turn this 2 into a 6. Let's see if I can turn it into a 6. Okay, so there's a 6. Let me just get rid of that. There you go. Hopefully you can see that. Okay, and that's a 6. All right, and then this one is going to also be a 6. So that's going to be added. Let's just see if I can get rid of that. There we go. Okay, so there's your 6. Okay. Then, remember, we are timesing it by 3, so that means there are 3 BRs, and then we times that by 3 as well. Okay, and we've got our balanced equation. Okay, so that means the electrons are the same. That means then, now, I can cancel the electrons. Okay, so I can cancel the electrons, and then I can write the whole thing out. This is gaining, this is losing. So I can just literally just combine the reactants together without the electrons because they've cancelled. Okay, so that means you have got 3BRO minus plus Fe2O3 plus 2H2O. Okay, and I'll explain the 2H2O in a minute, which then goes to 3Br minus plus 2FeO4 2 minus, okay, plus 4H plus. Okay, so I'm going to explain the H pluses and the waters. Now remember, the 3 waters there, there's 5 there. So the difference between 3 and 5 is 2, and there's more on this side, so they cancel, the waters cancel, so that's why there's 2 waters. Then you've got 10 H's, that side 6, the difference between those and those is 4. Those 6 cancel, and then the 4 remain on the other side. Okay, and that is how you take 2 half equations that are in acidic conditions, okay, balance them, and then make a full equation afterwards. So the next question is talking about transition metal ion colours and electrode potentials. Now, if you haven't done transition metal ion colours before, I will tell you the colours as we go through, so do not worry. Okay, but if you want to, go ahead and look at the transition metal colours video. Now, if we look at this, it looks really daunting because it's a lot of electrode potentials, all written as reduction. Okay, and it has two reactions that's going on, and it's trying to tell you for each experiment, identify the species causing the observation shown in bold, and write for any reactions taking place. You don't need your state symbols. So I need you to have a look at this, and you can look at it in different ways. First of all, you're going to immediately think, oh, I need to use this, but actually common sense can prevail as well. So let's have a look at this first of all. If you look at the green, okay, what is the green? So let's put this down here, and then I've highlighted what the green is. So you look here, the green is the Fe2+, okay, and you see it here and here. Okay, that's just your normal metal. Okay, and your brown is your Fe3+. So yeah, that's the thing. Now, if that is the case, let's have a look at the ion filings here. So the ion filings added to dilute hydrochloric acid. Think about that. You've done this since year 9 or form 3 or whatever you want to call that year at the stage in your school, in your year. Okay, and you've done it in your GCSEs, and you've done it. Well, a metal plus an acid goes to salt plus hydrogen. Okay, and the question says a green solution forms and gas bubbles are seen. That's a metal plus an acid. So what do you think you're going to see? Right, okay, so the first of all we're going to see is iron plus our hydrochloric acid, okay, which we've got over here. If I put it like that, kind of makes sense, doesn't it? Iron plus hydrochloric acid. Okay, it's metal plus iron. So let's just iron plus HCl. Okay, so if the iron plus HCl, it says here that it's the green one because it says green solution, so it's Fe2+. So if it's Fe2+, then that means you get FeCl2, okay? Now, the gas, I said, is hydrogen. Okay, so there we have that, and then all we have to do is balance, because it said give any equations for any reactions that happen. So here we have Fe plus that. Right, okay, what do we need to do? We put in 2 there. Okay, oh, and that balances. And that, perfect, right. Don't need state symbols. He didn't say we needed state symbols. Okay, so I'm done. So number 1 is done. And remember, this is your green one. Let's just see if my green pen works. This is your green one, okay? So we're then going to go from here. The student bubbles hydrogen peroxide in there. Now, you don't know that reaction. You don't know what happens. But fortunately for you, down here is the hydrogen peroxide, okay? So the hydrogen peroxide is here. So we have got hydrogen peroxide. We know that that has electrode potential of 1.78. We know that we've made this stuff, which is here, yeah? And that's 0.77. Okay, so 0.77. Well, that means the hydrogen peroxide will gain electrons, and that means the iron will lose electrons and go to ion 3, okay? So we've got to then say, right, okay, why does that happen? Okay, so in your question, normally what you would say is this, is the following. You would say that the electrode potential of the H2O2, okay, is greater than the electrode potential of the iron 2+, okay, and iron 3+. Okay, so basically that is it. That means H2O2 gains electrons. Okay, so that gains electrons. And that means if you put the equations in, that's got 2 equations. Now we're going to do the equation. That's got 1. Okay, so balancing wise, all I have to do is times this one by 2 to make it balance with this. Remember, this is going to lose. Okay, so if that's going to lose, it's going to be starting off with Fe2+. It's going to go this way. Going to go this way. So basically that would be Fe2+. And remember, I want 2 electrons to cancel out those 2 electrons. So there's going to be 2 of them. Okay. And then I'm going to add together this bit there. Remember, the electrons cancel. Plus 2H2O2 plus, I'm just copying it out, 2H plus. Okay. Okay, and then we've got that. And then we go, right, okay, what have we got? We are making Fe3+ from that. So that is 2 Fe3 plus the products there, which is 2H2O. Okay. So all I've done is use my sensor to say, okay, green solution. Okay, that's my Fe2+, that's my connection. That tells me I've got FeCl2. Iron filings, metal plus hydrochloric acid, salt plus hydrogen. Okay, and then I've done a little bit of explanation to say that this is a greater electrode potential than this, therefore the H2O2 gains electrons, and you can also say the iron loses electrons if you want. Okay, and then I've combined my two together to give an equation. Okay, this is not an easy question at all. Okay, so remember, if you're given a table of data, you've got to use that table of data. Okay, so that may, hopefully that makes sense.